So I'm determining the line of intersection between two planes. The first thing I'm going to check for is to make sure the planes aren't parallel. So I'll number these equation 1 and equation 2, or plane 1 and plane 2. The normal for equation 1 is -5, 3, -2. The normal for equation 2 is 8, -2, 2, which can reduce, or we can factor out a 2 and get 4, -1, 1. Now both of these are reduced as low as they can go in normals, so these two are clearly not scalar multiples. So not parallel. So that means I can solve this system to find a line of intersection. So to do that, I'm going to start by eliminating one variable. And so I want to look for something that's easy to eliminate. If I look here, I see that the coefficient to z on both equations is the same number but opposite signs. So that's the easiest one to eliminate. So I'm going to eliminate z by subtracting. You don't have to write this part down, by adding. So if I add these two equations together, I get 3x plus y plus 0 z's, which I don't need to write down, plus 9 equals 0. So that is kind of close to my equation of my plane. I'm going to pick a variable to isolate, and if I look at those two, y doesn't have a coefficient, so this is the easiest to isolate. So if I rearrange that equation, I get y is equal to -9 minus 3x. So that's going to be one of our parametric equations. We just have to get a parameter in there. So I'm going to let x equal t, where t is a real number. So that's my first parametric equation. And subbing that in, I get y equals -3 minus 3t as my second parametric equation. And now I just need an equation in z. So I'm going to substitute these two equations into one of these two to solve for z. So you pick your favorite. It really doesn't matter. I'm going to sub x equals t and y equals -9 minus 3t into, let's say, equation 1. So if I do that, I get -5 times t plus 3 times -9 minus 3t minus 2z plus 8 equals 0. So I've just replaced the x and the y with my new equations. And I'm going to simplify that. So I get -5t. You probably don't need me to talk through this. Hopefully I do this all right. And I want to isolate z. So I'll keep going on this. That's my t's can go together. That's -14t. My constants can go together. That's -19 minus 2z equals 0. So I'm going to isolate z. -2z equals 19 plus 14t. Divide through by -2. And I get z equals -19 over 2 plus 14 over 2 plus 7t. So that is the third of my parametric equations. If I put this together into a vector equation, I get r is equal to my x-coordinate of my point is 0. My y component is -9, and my z component is -19 over 2, plus t times, for x it's 1, for y it's -3, and for z it's 7. So that's my line of intersection, is the line of intersection. That's it.